Well, hello everyone. Today I'm Siddhant and I'm here to present a report on my project, which was comparative analysis for zero frequency, minimum mean square error, zero frequency with successive interference cancellation, and maximum likelihood equalization techniques for MIMO architecture, in which I'll discuss the effect of all these equalization techniques on the bit error rate for the MIMO architecture. I'll start off with the introduction. Multiple input, multiple output technology is a wireless technology that uses multiple transmitters and receivers to transfer more data at the same time by using natural radio wave phenomenon like the multipath. Multipath originally caused interference and slowed down the wireless signals, but the MIMO technology uses multiple and smart transmitter antennas and receiver antennas with an added spatial dimension to substantially increase the data rates, high spectrum efficiency, especially in low interference environments, and increase the system capacity and range using multipath technology. This is done by enabling them to combine the data streams from different paths, hence increasing the signal capturing power. It also spreads the same transmission power over the antennas to achieve an array gain which increases the spectral efficiency and a diversity gain that improves the link reliability. In the MIMO, the data bits to be sent are encoded and interleaved. A symbol mapper is then used to delineate these embedded codes to the data symbols like PSK, QM, etc. In the recent developments, which are a proof that optimum use of multipath channels can lead to associated relative designs and can gigantically improve the magnitude of transmission in case of the wireless channels. The efficiency for communication channels is largely affected by the signal processing methods that are to be used. The bit error rate is significantly affected by the fading in various paths and due to the Doppler shift. Unlike the added white Gaussian noise or the AWGN channel, the channel impairments which lead to the damage of the received signal can be baleful. Techniques that are used to curb this are equalization, diversity, and channel coding. The intersymbol interference is mostly caused by signals surpassing its range in the coherence bandwidth and leading into the modulated bandwidth, which can be minimized by the use of equalizers, which use the fact that the channel is sturdily time varying and robust in nature. The MIMO system model. By definition itself, MIMO technologies has multiple antennas on both the transmitter and the receiver side. In case of the MIMO system, different types of gains can be realized by making use of a large number of paths between the transmitter and the receiver. The data is not transmitted serially but in parallel. The total power which was initially being given is now divided by the total number of antennas, and using this technique and this fact of the division of power, the total cost associated with it can be reduced exponentially. This is one of the main reasons that it is one of the backbone technologies in case of the third and fourth wireless communication system. The fact that the data is transmitted parallelly helps in reducing the cost of designing antennas significantly. This helps to increase the data rate as well. Hence, in case of the MIMO technology, multiple streams of data which are parallel to each other are convoluted in space using signal processing. The zero enforcing equalization technique in MIMO receiver. For the zero forcing technique, it was first introduced by Lucky. In this case, the equalizer follows the combined channel samples and has an impulse response of 0. Such a receiver can be realized when the coefficients are allowed to go out of bound. For a filter assuming the delay between coefficients as t, the frequency response can be periodic with a rate 1 divided by t. Filter is assumed to provide null intersymbol interference throughout the entire bandwidth. For practical considerations and to make it somewhat realistic for the world, a much smaller response in size is taken. The problem associated with the zero frequency equalization technique is that it does not consider the effect of noise, and due to this fact, the noise may be amplified during the process of eliminating the interference. This amplification of noise mostly occurs at frequencies providing high attenuation, as a result of which the optimal detector becomes really complicated due to the presence of noise. Maximum minimum mean square error equalization techniques for MIMO receiver. The MMSE tries to maintain a steady balance between cancellation of interference and amplification of noise. Either the output SNR, the mean square error between transmitted symbols, or the output of detected signals is taken as the parameter. The mean is reduced to a minima by considering the Bayesian approach, which considers both the transmitters and receivers to be random. The filter tries to minimize the expected value of the square of error signal, which is the difference of the filter output and the transmitted signal. At low values of the signal to noise ratio, the power transmitted is low and the value of sigma n square is also high. At high value of signal to noise ratio, it is reversed. That is, the power transmitted is high and the value of sigma n square is very low. This helps to narrow down the approximation of MMSE to that of a matched filter. The maximum equalization technique. In case of the maximum equalization techniques, it calculates the Euclidean distance between all the received signal vectors and the product of all possible transmitted signal vectors within a given channel H. Maximum optimum detection is made using a maximum a posteriority detection. The optimal error detection coding is performed, which is best for minimizing the error. The results obtained in this case are the best among all the equalization techniques and are near to the theoretical value. The drawback that is associated with the maximum likelihood equalization technique is that as compared to other equalization techniques, it is much more complex, and the amount of complexity increases as we increase the number of antennas, and to further make the situation more complex, the complexity increase is also exponential. Zero frequency successive interference cancellation equalization. In this case, the output of the already detected signals is used to influence the output of the incoming signals. The output is affected by reducing the value of the estimated signal. In case of the zero frequency, the problem associated with it is that there is a lot of noise amplification, and SIC's main purpose is to reduce that noise amplification. The noise is reduced by the nulling factor. After completion of one operation, the first row of the matrix becomes redundant and is eliminated, which also reduces the dimension of matrix by 1. The simulation. Now, while simulating all the channel and all these techniques for calculating the bit error rate, a few considerations were taken into account. First of all, the MIMO system that had been used for simulation was a 2x2 MIMO system which had an equal number of transmitter and receiver antennas, which were 2. In order to get realistic simulations that are compatible with the existing in the real world, the channel was assumed to be relay fading channel. The additive wide Gaussian noise, which had a variance of 0 dB, was also used. The type of modulation technique that was used in this case was binary phase shift keying, or BPSK. In case of BPSK, there are 2 bits associated with it and each has an equal probability of 0.5. After modulation, the symbols are multiplied with the channel and then the additive wide Gaussian noise is added to it. Then the equalization is performed on the received signal using different equalizers, which are then demodulated, and the plot for various simulations is then taken. While taking the plot, it was considered the MIMO system for 1 transmitter and 2 receivers with a maximum combining ratio as a theoretical value for comparison basis only. In case of the zero frequency and zero frequency successive interference cancellation simulations, we can see that there is a lot of difference between the theoretical value and the simulated value. Especially in case of the zero frequency equalization, zero forcing equalization, we can see that there is a lot of difference, especially in case of the theoretical and the simulated value. This is mostly can be accounted to the fact that it does not consider the noise amplification, and as a result of which there is a lot of difference. In case of the zero frequency zero forcing successive interference cancellation simulation, due to it making use of the fact that the already obtained signal can be used in order to influence the incoming signals, there is some reduction in the bit error rate value, but still it is still quite far as compared to the original desired theoretical value. In case of simulations for the MMSE and the ML equalizations, we see that they are better as compared to the zero forcing equalizations, but still in case of MMSE, there is a lot of difference between the theoretical value that is supposed to occur and the simulated value that we get. It has also been described above that ML is the best equalization technique, and this is definitely proved from this graph. In this case, the simulated value is much close as compared to the theoretical value, giving the lowest possible value for bit error rate among all the equalization techniques that have been used, making ML equalization the best equalization technique. Now this is a graph that compares the bit error rate value for all the equalizations among themselves in order to justify which is the best one. As you can see, the best in this case is the maximum likelihood equalization technique. The only problem that is associated with the maximum likelihood equalization techniques is that it is really complex to implement, and since it's just been used for BPSK, which has just 2 bits, as the modulation kind of increases, the complexity of designing this thing also increases, as a result of which it is really complex in order to make it realistically possible. Thus it can actually be seen that among all the equalization techniques, the ML techniques is the best one. Well, I would like to thank Dr. Daipang Wu for all his contribution and his extreme valuable guidance throughout the course of the semester. Thank you.